Welcome to my talk on expanding your Visual Studio arsenal, tips and tricks to improve your skills. This is an open session, and a little bit about myself. I'm Stace Hindle, a lead programmer at Sumo Sheffield. I've spent almost 2 decades with Sumo, and it's been a privilege to work on a great number of titles. So what do I want to cover in this presentation? It's going to be quite a quick ride, because I've got a lot to cover. I want to go over some of my favourite keyboard shortcuts, what you can do with breakpoints beyond just pausing execution. We'll cover the different types of watch window and a few things you may have been unaware of. And finally, remote debugging and how you can set this up, what you can do with dump files. And I hope by the end of this talk you have picked up a few tips and tricks that will improve your Visual Studio skills. So, shortcuts. One of the things I like about my job is supporting others, and typically I used to be able to sit down with them in the office and see how they use their machine. Unfortunately, with that all being remote now, we've got to do things differently, but taking your hands away from the keyboard to use a mouse slows you down. You should try and learn what keyboard shortcuts are available and make a cheat sheet for yourself. To kick this off, where can you learn about the available shortcuts? Well, the help menu has a link to a cheat sheet and a huge list of available shortcuts. Be aware, these are all based off of default keyboard bindings. If you've opted for Visual Studio C++6 shortcuts on the first startup, some of these may not work, but you can easily change the default mappings from the environment keyboard options. You should also check out the edit menu. The advanced section has some useful ones, such as expanding the selection and sorting of lines. And if you've not tried automatic document formatting before, it's very useful. You can even use your own custom Clang format file to keep your project consistent layout. Now, some very basic operations that are often overlooked. The ability to jump the cursor whole words at a time by holding down the Control key and using the left or right arrow keys. You can also delete whole words by using Control Delete or Control Backspace. I didn't know this until a few years ago when I watched a video on speed typing. If you want to copy or cut a single line of code, there's no need to highlight that line first. Simply Control C and that whole line will be automatically used. And if you want to move a line or a selection up or down, hold the Alt key and use the arrow up or down. Navigation. While editing a header or source file, you can quickly switch between them. Use Control K, Control O. Note that you don't need to release the Control key between these two key operations. If you have a cursor on a function, quickly jump between the declaration and the definition with F12. Or if you have a variable selected, it will take you to the declaration. If you have a type selected, it will take you to a definition. Using Shift F12 on a type function or variable will open the Find All references window, and this will show you where that object is referenced throughout the solution. Searching. Now, if you want to find a file in your solution, use Control semicolon to filter files in the Explorer view. Note that you can do partial matches, so use a space between words if you're not sure of the exact file name. If you have a file open in the edit window and would like to see where it lives in the solution, use Control left square bracket followed by S. The feature search helps you find and access Visual Studio features that may be hard to locate. They may be hidden in a menu somewhere. Opening the keyboard bindings menu, which will allow you to hunt for the options easily, press Control Q and type keybind. The all-in-one search can be accessed with Control T, and that gives you a way to search through your code with various options to filter by just a file name, type, member, or plain text. So check that one out. You can quickly surround any code that you've got with parentheses, curly brace, or a square bracket. So select that code and press the opening brace key. Code snippets are a fantastic way to surround blocks of code. Here, demonstrating what you could do with a hash if or a for loop. Simply press Ctrl-K, Ctrl-S to bring up the menu. These can also be custom defined. Also, it's quick and easy to block comment code. Select the code, hold Ctrl-Shift and press the / key. Now let's move on and look at what we can do with watch windows. There are many types of watch window: auto, local, watch, parallel, data tips, quick watch, and the immediate window. Next we'll cover these in a bit more detail. So, taking a look at different types of watch window with an example here. For this, I'm going to use a crude database example that we can query to find a person by age. Firstly, we've got the auto window. This shows anything that's around the current point of execution, so I think it's 3 lines above. Locals is anything that is available in the scope. Note that we've got a couple of uninitialized values, and this is because we've not initialized those yet. Our watch window, where we can specify any values we want to monitor. My favorite way of populating is to use the drag and drop. And the immediate window, which we typically have to open on first use. From the immediate window, you can issue complex commands or just use it as a scratch pad. Here, if you actually select the previous instruction and continue typing, it will automatically copy it, and that's a very useful way of reissuing a command. You can also use it for any other general queries. Next, a really useful feature of the watch window. If you're stepping through your code, it can capture the return values of functions. Here we have stored the mean age as a result of dividing the sum of ages by the count. But what if we wanted to know what those individual functions returned? Well, if you step through the code, you can see those individual return values in the autos window. Next, going to cover format specifiers. So, if we go just down a little bit further to where I've got a pointer of values that come from a database. So raw pointer, the debugger only knows about the first entry. This is because it doesn't know the size of the array. If you're using a container with defined a visualizer, it might automatically show the full set for you. But if you know the count that you've got, you can use the format specifiers. So all we need is a comma, and we're going to use 8, which we know is our count. Alternatively, if you know this is a heap allocated array, if you can use comma HV, that will automatically add the full list into your watch window. You could obviously put any number you want into here. Next, I'm going to demonstrate how we can show 3 elements that start from the 3rd position, but this is a little fiddly. You do need to make sure, if you're going to take something from the middle of an array, that you take the address of it like this. Although I do note that it will start from 0 index again. It's a little bit misleading. Now, you can actually search within some of the results that you got in the watch window. This is easily overlooked. Just simply go to the search option. And here I'm going to search for all mentions of Harry. Simply type it in. Now note that the default search depth into structures and classes is 3, but that could be controlled. You can choose to reduce what's visible by pinning the members you are interested in. Here I'm going to change it so that it only displays the person's first name and age. If you wanted, you can also hide those non-pin members in the structure. Do that from the toolbar. Note that member names are now hidden, but you can show them again with this toolbar option. Data tips. These are a great way to track a few individual values in the edit window. However, by default, they can be fiddly to work with. If your mouse strays a little too far outside the boxes, they will automatically close. To fix this, head to the Options menu, search for Tips, and enable Keep Expanded Data Tips until clicked away. This makes them much easier to work with. Now you can see they're retained. You need to click the mouse for them to close. Now, just as you can pin members in the watch window, you can also pin data tips. This will actually keep them and affect the watch window below as well. Our key feature of data tips is the ability to pin them into the source code, and this means that they will stay next to any code even when scrolling, and that position can be adjusted. You can even add comments. Gives it a little bit more context. And if you don't want it pinned to the source itself, you can have it as a floating window. Now, let's take a look at some more watch specifiers and expressions. One thing we can do is view all of our values as hexadecimal from the context menu. This will affect the watch window and on any data tips. But you can also do this on an individual value with a specifier, here, H for hexadecimal. You may have noticed a list of specifiers are popping up. We could also switch to something like B for binary. There's a whole bunch there, E for scientific notation, or SB for strings without quotation marks. We can also execute functions. In this case, we'll call the getCount function on the database class. You can also call functions that require a parameter, though note, you cannot construct any new types, so classes and structures in the parameter list are not possible. Now be aware, calling functions can modify state, so you have to be very careful. Let's take a look at text visualizers. Looking at a string of HTML, you can see the standard view is plain text. Useful as we can view the whole string and copy the content, but we could do better. We could change the visualizer so it views as HTML. Now it's clearly rendered as HTML. You can also view JSON. The visualizer for this is a convenient tree to view the content. Much easier to work with. And if you're doing some web development, dealing with base64 encoded strings, you can easily get those decoded from within the visualizer menu. This is so much easier than it used to be. Now, this is not a watch window, but is a cool new feature to look at the size alignment of a class in memory. Those who are familiar with optimizing your memory footprint and packing for cache line efficiency will know all about this, but it's not always obvious. In the past I've used an external tool for this, but it's really good now to see it straight in the editor. And for a very simple case here, I've got two structures, both contain exactly the same information, but they've got a different ordering to the variables. So for a very simple size calculation, I assumed a whole byte for our bit field because of the char type. So I estimate 24 bytes will be used for this structure. But now let's have a look by moving the mouse over the structure name. Well, this is the new bit, and it's actually showing us it takes up 48 bytes, twice what we thought. Now, selecting the memory layout, we can see how this is actually padded out. From here, we've got a lovely table. It shows lots of empty space that's inserted by the compiler by default to make sure our data is appropriately aligned for memory access. Now, going to the detail of what makes a good layout is case specific, but let's go back and take a look at the other good structure. As we can see, it's being reported as 24 bytes, and this is only after we rearranged by size. So, what does that look like? Well, as you can see, bit packing has managed to cram the two bit fields together, but we've still ended up with 1 byte of padding before the integer. But this is a lot better than it was in the previous example. Now for some additional tips. You can actually show the parameter values that have been passed through into the functions in the call stack. Simply bring up the context menu and show parameter values. You can also create your own visualizer for custom data types shown in the watch windows. To do this, you want to create a NatViz file, which is written in XML. But this is quite complex and fiddly, so I do suggest you look that one up properly. Now, let's take a look at breakpoints and what we can do with them. We all know how to use a breakpoint to get the debugger to stop execution at a location in the code. But did you know that you can add debug output into your running code with a breakpoint? Let's run through a list of the different types of breakpoint according to the symbols. We have our traditional breakpoint, a conditional, or a hit count. These both have a plus symbol. Trace point is diamond shaped, and this one can output our string to our debug log. A temporary disable once hit has a clock, and a dependent has a dotted arrow. The dependent one will only be activated if a previous breakpoint has been hit. And this is what they would all look like in the breakpoint window. Now, let's take a look at how you can create these various types of breakpoints. You can left click in a breakpoint column, followed by a right click to bring up context menu, and then click conditions to bring up settings menu. You can type in here a logical expression that should trigger on the breakpoint. Use any local variables, or alternatively, you can check for a set number of hits, or a filter, which is most useful if you're multi-thread debugging. You can set it to an action. This is where the outputs are debug strings into the log. Note that any variables here need to be in curly braces. Trigger once option, and if you want to do dependencies, you select an existing breakpoint from here. Alternatively, if you just right click in the breakpoint column, you can select one of the types that you want to create. Now, let's take a look at each of the breakpoint types in action. This example will use a while loop to demonstrate the individual breakpoints as it iterates around the loop. We'll start by hitting the basic breakpoint. You can see all the breakpoints are enabled except the dependent one down here, which is disabled at present. As we continue on, we'll hit our break once breakpoint. This has now been disabled automatically. Next, we've hit the conditional breakpoint, where it was set to check if I is equal to 2. Note, we've been getting some debug output down here, and this is coming from our trace point, which is set to output the name and age. Now, after hitting the conditional breakpoint, our dependent was enabled. So continuing on, we finally hit that dependent breakpoint. And as you can see, we've now filled out the debug log with all of the people that were age checked from within the findPerson function. Now, I want to share another trick that I use if I want to tell how many times I went around that while loop before it exited. We can't use that local variable I as we'd left the scope, and let's pretend we can't count the number of debug lines we've output there. So where I'd set in a breakpoint that had a very high hit count, you can actually see that we went around the loop and passed that breakpoint 7 times. I find this very useful if I want to find out how many times a function has been called during a frame, for example. Now let's take a look at data breakpoints. These are created a little differently and are great if you want to track down why a value has been changing in memory. This is just a standard memory layout view, and you can see some bytes that have been changed. This could be an intentional change, or memory corruption. But you can add in breakpoints that check for 1, 2, 4 or 8 bytes that have been changed at a given address. Though do note, you can only have 4 breakpoints active at a time, and this is because the x86 CPU only has 4 hardware registers to support this. This example, we're going to output the same string twice. The output should be the same, as I'm unaware of any changes that could have happened between the 2 output lines. However, when we continue execution, you can see that the age has changed unexpectedly. To track this, we could use a data breakpoint. So let's set one up, knowing that the age value is what was changing, and there are 2 approaches that we could use to add a data breakpoint. The traditional method was to go to the New option, select Data Breakpoint, and drop in the address that you were interested in here. Thankfully, you can do it by variable name, but remember to use the ampersand to get the address. Now, the new approach is you can actually bring something down into the watch window. And if you right-click on the variable itself, you can say break when value changes. Now you can see in the watch window there is a new breakpoint icon. And when we continued execution, we can see the point in execution where the variable was changed. Now, some extra bits on breakpoints. You can actually create function breakpoints, breakpoint groups, and assign breakpoint labels. Take a look at function breakpoints. This is a really simple example, but can be useful if you have functions hidden away in a library and you know the symbol name for it, but you don't have the source. Or you'd like to add breakpoints quickly to a function that has many overloads. Here we'll add a breakpoint to the find person functions. Go to New Breakpoint, select Function Breakpoint and type in the name. As you can see, the breakpoints have now been added. And this leads us on to breakpoint groups. As it found multiple functions, it automatically created a group for them. You can create as many groups as you like, so I'll add one that includes these 2 other existing breakpoints in our main function. The beauty of groups is that you can now toggle a whole bunch of breakpoints in one go. Moving on to the last point, which is labels. Labels allow you to tag breakpoints to add extra context information. A breakpoint can have many labels. Here I only add in the 1, but once a label is created, you can assign it to other breakpoints as well. When they've got a label assigned, you can now use the label column to sort them. Breakpoint debugging. So now I want to cover some points about debugging with breakpoints, some problems with threads, how we can use the parallel watch window, visualizing thread locations, freezing and thawing those threads, and using a breakpoint thread filter. I've got an example of a parallel for loop that's going to demonstrate what happens when a breakpoint is hit by multiple threads. In this example, I've got a bunch of local variables in the watch window, and I've also placed them into the parallel watch window to show the difference and how these views are represented when a switch in context happens. Now as I step through the code, you'll notice it started to jump all over the place. This little blue icon indicates that the thread context has changed. So, our normal watch window, as it switches context, shows all the values changing, but the parallel watch window shows everything according to thread ID, and this makes it much easier to see and track what's happening on each thread. To see where our threads are in the actual source code, you can turn on the Show Thread in Source button. This comes in handy so you can see where each of the threads is in the breakpoint sidebar, and as you step through you can see these are continuously updating. Note that this can slow the debugger down, so don't leave it on all the time. If you get into the situation where you're trying to debug one single thread and you're finding it difficult, you can actually go to the threads window. If you select all the threads, you can then freeze them or just pause them. But do remember to leave the thread that you're interested in as running. Now as we step through, hopefully it should step on that single thread as expected. Once you're ready to continue your normal execution, do remember to unfreeze or thaw all of those threads. Now, to go back to one of the breakpoint filters that we saw before, you can actually make it so that the breakpoint will only trigger on a given thread ID or name. So you can edit the condition of a breakpoint and set that up as a filter. And now, when it executes, only that thread should stop in the debugger. Note that this can slow execution down as well, so use sparingly. A couple of notes on using breakpoints. You can export and import breakpoints. This could be really useful if you wanted to set a breakpoints for a particular bug debugging task, or to share with others. Conditional breakpoints are slow, as each time the breakpoint is triggered, it jumps back to Visual Studio to evaluate. So too many and you'll see a noticeable slowdown. Data breakpoints are dependent on the memory addresses that they are allocated at runtime. So they are unlikely to work between different runs of the process. So you'll need to recreate them each time. And function breakpoints, much like variables, can be tricky to define if they are within a dynamic link library. So you'll need to fully qualify them for Visual Studio to find them. And moving on to our last section, remote debugging. Remote debugging is the act of attaching to a running process on another machine. In this example, we'll connect to another Windows machine running an application that simply hangs in a while loop. So on the user's machine, you want to debug, share with them MSVS-Mon application. This can be found in the debugging tools. You can stick this on a network share for easy access. And once they've got it running, it should be ready for you to connect. So back on your local PC, open up Visual Studio and attach to process. Change the connection target to use their machine name or IP, and once connected, you should be able to filter through to the running application. Then once attached to it, you can pause, and it should act as if you're debugging locally. You can now step through and view any of the variables. Note that you may need to fiddle with the user permissions on the remote machine to get the connection allowed. And another approach to remote debugging is to use a dump file. So what is a dump file? Well, if you don't have the luxury of being able to remote debug, think of them as a save game for the debugger. They're a snapshot of an application at a point in time. It will contain the call stack of each thread, a record of any execution information, and a memory capture. A full dump will contain the heap allocations and could potentially be many gigabytes in size, or a mini dump, which only contains local stack variables, should be just a few kilobytes to megabytes. Effective debugging with a dump file requires that you have symbols available that match the compiled executable and source code. So I recommend source indexing where possible. This will allow Visual Studio to automatically obtain matching source from a source control system like Perforce. Now let's have a look at how we can create a dump file from within Visual Studio. In this case, we'll use an application that hangs in a while loop. After pausing execution, we can see that we're stuck in a loop. Going back to our main function, we can actually see some strings that I've got allocated, one from the heap and a local. If you go to the debug menu, you can then choose to save out a dump file. From here, you get the choice of a full or a mini dump. I'll demonstrate a mini dump here to show the difference when the heap is not available. When you've got a mini dump, You can open it by dragging and dropping, or just use the File Open menu. Once this is open, you'll see a summary screen. It might tell you some information about why the dump was created, such as exception information. Then you need to pick to debug the target. I go with mixed debug. Now you can see exactly where we were when the dump was created. You see the values in the watch window. Do note that the heap allocated string here is not available. So that's the limitation of going with the mini dump. Have you had those requests where a user says, "Help, the application has crashed"? You say, "Well, what's the crash? What did you do?" "Well, the program doesn't let me do anything, it's stuck." You say, "It's not a crash, it's hung. Let's grab a crash dump that you can send me." How do I do that? Well, here we have the same example program which hangs in the while loop. While the user may not have a debugger, they can bring up Task Manager. Simply find the process, open up the context menu. Here I've actually got debug because I have Visual Studio installed. But what you want to ask the user to do is create dump file. Now this will be a full memory dump, a full heap dump, so it could take some time for them to save out. But simply ask them to zip it up and send it over to you. Did you know that Windows has a built-in way to automatically create crash dump files? Well, this little known feature is a real help if you don't have a crash handler for your application, and that your application shuts down before you have a chance to use something like Task Manager. This can be done by tweaking the registry, and you can tell Windows where you'd like to store off those files when the application crashes. You can create a specific application set of rules by using that folder name and setting the executable name, or if you set it at the root of the local dumps folder, this will apply to all applications that crash. It's really easy to share these settings. Simply save them out as a Windows registration file. Share that file, and when they import it, they should get the right settings. And the values of these settings allow you to specify where you would like dump files created, how many dump files to keep in that folder, and this stops you accidentally filling up your hard drive, and what type. So you could create a custom, mini, or full. Typically, if you've opted for this approach, you probably want to go with a full. So to close this, some takeaways. Shortcuts save you time. Take some time to learn them. There are many types of watch window. Each has its own benefits and special features. You can customize your breakpoints to stop under specific conditions or output debug information. Crash dumps and remote debugging are invaluable for analyzing hangs and crashes, so definitely try and use them. And we all have a tip or trick to share, so help others and teach them something. As a follow-on from this, I'm going to suggest you check out Advanced Debugging in Unreal Engine by R.A. Arnbjørnsen for a whole heap of additional tips. And that brings us to the end of my talk on expanding your Visual Studio arsenal, tips and tricks to improve your skills. Thank you for listening, and I hope you've learned something new that you can't wait to try out.
Absolutely. For taking the time not only to write the talk but to present it and put it together. Now we don't have any questions as of yet, so I'm just going to hand over to you if you want to say any shout outs at all.
Thank you. Yeah, well, I mean, it's been great to put the presentation together, and I can see obviously from all of the people giving me a wave or clap there. Thank you for watching. It's appreciated that you're all taking the time to watch this, and I've even got eyes in the academy, and I can see you've all been watching as well, which is fantastic.
Absolutely fantastic. It has been great seeing everybody engage, not only with obviously the talk, but just in the chat, sort of saying that there's lots of information that they didn't know. And obviously we were talking just before we came on, and I was like, wow, I didn't know that. I only sort of know like Windows V to open my clipboard and tiny things like that. So it just goes to show how important this time is to have these talks, and also just to share this knowledge. Now we're just going to wait just for a couple of minutes, just in case people are typing any questions. Sometimes you just got to digest that information to be able to regurgitate a question. But if we don't get any, are you happy to be contacted, obviously via Teams or via email?
Yeah.
Is that cool?
Yeah, no, absolutely fine. I know there was lots of things presented there, and I hope obviously people just want to go away and try a few of those suggestions. I can just see from the chat, people were saying, how many times did VS crash on me? Well, actually, using plain Visual Studio 2022, I hardly have that problem anymore. But I've tried to keep obviously this talk just down to the base installation, not using extensions and things like that, which is where I've encountered a lot of problems in the past. But I'm aware, depending on your project, you can get tied to even Visual Studio 2017. So it's something I suggest. Try and get yourself up if you onto newer versions if possible. It's a lot more stable.
Fabulous. So we've started to have a couple of questions come through. So one of them is from Denis Chavankov, and it says, any specific tips to debugging in Unreal?
Oh, actually, there is a whole host of those, and I did put a mention just at the end to Ariane Bronson's debugging in Unreal, and I suggest that you actually just check that one out, because that's got even more tips that focus specifically in Unreal. So I tried to keep mine separate and cover a lot of things just in Visual Studio, but that's why I'm definitely recommending go over there if you want to see something about Unreal.
Fabulous. And then we've got another question from Oliver Smith that says, if you could request a new Visual Studio feature / shortcut, what would you want?
Oh, I'd actually quite like them to bring back macros. It's one feature that they had in there a long time ago, and I found some nifty ways of using it. You can obviously make your own extensions. You can script a lot of stuff yourself, but there was something just about having that macro button and be able to click a whole bunch of actions to automate some things. I do miss that and would like it to come back.
Fantastic. And then I'm just going to move on to one more question, which is from Dave Chapman, which says, with all these shortcuts, do you find you're no longer using Visual Assist as much?
Oh, interesting one. Visual Assist, I have found is fantastic and useful. I have to admit, I use Rider quite a bit nowadays, but I swap between the two depending on what I'm actually doing. Visual Assist definitely indexes the functions and the files, and you can interact with it very quickly. It's a lot snappier than Microsoft have managed to make Visual Studio, but Visual Studio is improving. They keep watching the release notes, and I do see improvements. But then there's a lot of competing extensions, and I definitely wanted to not cover everything under the sun that I would like to have, just because of time limits in this one. But Visual Assist is good. I've also found that unreliable sometimes as well. So I wouldn't say any of these tools are a perfect solution. Not at the moment, unfortunately. But it's still a good tool.
Very, very good. Now, this one isn't so much a question, it's just a tip to share from Andy Chapman, who says Visual Studio has multiple cursors feature that's worth looking into. This allows you to edit in multiple places at the same time. So that is it.
Yeah, that feature does. I had that on my list to cover, but I found it a little bit tricky to demonstrate it in a sensible way. But certainly one for people to investigate. And there's a whole host of things you can do with find and replace and regular expressions and things. Too much to list, unfortunately.
Well, thank you so much, though, Stace, once again for just your time, but also for putting this talk together. If anybody does have any further questions that you want to sort of discuss and continue the conversation offline with Stace, please reach out. And just thank you all for being here and just for taking the time. So that's it from me. I'm going to say au revoir and all the best and have a lovely rest of your day.
Cheers.
Fantastic.
Thank you all.
See you later. Bye.
Bye-bye.